Welcome everybody. So this will be a very short live coding webinar on subscription queries, an exciting new feature of Axon 3.3. So to introduce it, I'm going to start by looking at an application that currently doesn't have subscription queries. And then we're going to build them in to improve the application. So that will give you practical insight in how to use it. So let me just start up the application and then run it in my browser so you get an idea of what it does and where subscription queries fit in. For those that have attended some of my other live coding webinars, this is again about our gift card demo domain. We're using gift cards as a demo because they are conceptually really easy. Gift cards get issued at a certain amount and then they get redeemed until their value is depleted. And that's about everything that happens. So that lends itself very well to a simple demo application that allows you to do these things. As you may have seen, all code is on GitHub. What I've actually done is just prior to this webinar, I've tagged my code as being in the state of the start of the webinar. So I will be modifying it during the webinar and then I'm going to push it again so you can see both the original version as well as the version with subscription queries built in. So this is the demo screen. Here we can issue commands, both issue a single gift card at a certain value, as well as redeem the card at a certain value. So here below we see a query model of currently created gift cards and their remaining value. As you see, it's empty. I can issue single cards here. So let's call it demo for 100. And nothing happens. I can refresh this query model and then you see it show up. Now in this case I have to press refresh explicitly also after redeeming. I'm going to redeem this now for 10. Nothing seems to happen, but if I press refresh you would see that the remaining value is 90. So in this case I have manual refresh. Now one very easy way of getting this fixed in this application would of course be to just automatically perform a refresh whenever a command has been executed. And while that would work more or less, it's not a real solution to do the refreshing for a couple of reasons. So it would force me to wait for the completion of the command. So it's very synchronous. I would be blocking something and that's not what you want to do for a high performance application. But also if you would think about multiple users working in this application at the same time, then if one of them does something with a gift card that's also in the view of another user, then that wouldn't be automatically updated if you would bind refresh to the completion of a command. So there's a couple of other things you could consider. You could do things like creating separate events to signal that the query model has been updated, but that would require custom events that don't really have anything to do with your domain. You could do things like polling on the query model, which is very ugly and a waste of resources. So there was until recently not a really nice way in Axon to update this query model dynamically. So that's where query models fit in. To show you some of their features, I've also included this filter here in the card ID query model. So I can filter for cards starting with a certain letter. So if I would press E here, then there is no card because there's no card starting with E. If I do D, then I do have the single card. And we'll see how that relates to the subscription queries later on. So let's look at the code. Here we go. So the code is a very basic Axon application running on Spring Boot. I have a command side that consists of the gift card aggregate itself, as well as two commands, the issue command and the redeem command, and their corresponding events, the issued event and the redeemed event. Then there's a read side. So the read side has explicit queries. This is all programmed in Vaadin, and the Vaadin data grid component happens to need two particular queries, one to count all the records and the other is to get the actual data. So there are two query objects representing that. There's a filter that represents filtering cards on a particular ID. There's the card summary thing, that's the actual JPA record that contains the read model data and that will send to our client when we need to transfer that data. And then there is the projection logic itself, which has two event handlers. to process two types of events, issued and redeemed, and then do something in the query model. And there's two query handlers to give actual answers. So that's where we are now. Nothing with subscription queries yet. So let's start to build that in. If we want to use subscription queries, Axon Framework needs Project Reactor. The subscription query API uses reactive flux and mono objects. That's actually an optional dependency of Axon, but we'll need to add that explicitly if you want to use this. So let's do that first. So that's the Project Reactor stuff called Reactor Core. And actually, we don't need this version. Now, secondly, the Axon query subscription queries technology relates to how Axon does that and how Axon pushes those updates on the QueryBus. An entirely different matter is how you would push those updates to your client, in this case, the browser. There are various technologies for that. In this case, I'm using Vaadin, and Vaadin has a very nice module for that called Vaadin Push. So I'm gonna include that as well. That will use either HTTP2 or WebSockets, whatever is available. So it's a nice abstraction, but it's secondary to the actual subscription query logic, in fact. So to enable the push stuff, I'm going to modify my Vaadin GUI. So I'm gonna give it a push annotation, which would enable this functionality on my GUI. And I'm gonna rip off this refresh button. We don't need that anymore. So where is it? Here, refresh button. So this is going away. So I'm only going to add that grid. And I don't need this anymore. So I've simplified my GUI somewhat. The refresh button is out and it's now push GUI. So next, we should decide how to expand our query model to do something with subscription queries. And in general, with CQRS, if you design query models, you don't start with the query model in mind. You start with the needs of your consumer in mind. What do they need? And then based on that, you create a specific query model. And just the same thing with subscription queries. So let's see. Here is the card summary data provider. That's the Vaadin class that will update the data. The thing that we have available here to push updates to our browsers is to call a fire event function. And the fire event function needs a data change event. There are a couple of different options. There's one to refresh a single record. So I can give this a certain card summary record. So this is an option I have. If I would get a new card summary from the query model, I could actually update that in my Vaadin table. So let's just, we don't need to do that here in the code, but we need to somehow bind that to an update, and we're going to see later how to do that. Let's comment it for now. And here, the other thing I can do, which would be appropriate probably if something changes with the total number of records, is to fire data change events, just saying there's something changed with the data, period. And in this case, Vaadin doesn't allow you to add a specific record or say anything about that. It will just simply do a new query from scratch, which means that if you look at what I can sensibly offer from the query model, is either if there is a redeem, a change in the single card summary, and then with Vaadin we can fire the data refresh event and it will update that single card. Or I can, and that's appropriate when we issue a new card, I can simply say something has changed, the count of cards has changed, and then we'll fire a data change event and everything will be queried from scratch. So those are the things we would need in the updates. Looking at my read side, I already have the class card summary to fire this data refresh event, so there is nothing I need to do for that. I would need to have a new response class to signal that something has changed about the count of cards. So let's create a new class for that. I'm going to call that count cards, card count changed event, or update to be precise. We're using Lombok here, so we'll create a value object out of that. So now we have that class. So now we need to modify our query model to actually issue those updates. It doesn't go by itself. That would be really great if we had that kind of magic. We don't. So we need to modify our projection to not only handle initial results, but also provide updates to queries. The way that we do that is by, first of all, injecting a new Axon 3.3 object called the query update emitter. So the query update emitter is an object that you can call from the context of your projection to publish updates to subscription queries, and then they will end up at the client side later on. And we'll see, that's the thing we will program after that. Let's first make sure that we publish the right updates. So if you look at the entire projection logic, we are not going to change those query handlers, because those query handlers are and will continue to be responsible for providing the initial results to queries. We're going to modify our event handlers to not only update the data in our read model, but also to publish the resulting changes to the read model to subscription queries. So we're going to do it like this. Here, if a new card has been issued, we're going to emit an update. We're going to emit this to all queries of type count card summaries. I'll talk about this predicate later. And in this case, because we saw that Vaden couldn't really use any more data, just needed the knowledge of the fact that something has been changed, we would simply do a card count changed update. So that's it. Now, the second argument, this function, is actually a predicate on queries, and it will allow us to select particular subscription query instances to which we're going to send this update. Now, in this case, we've seen that our GUI has this filtering functionality. And of course, if the ID of the new card that has been issued doesn't match that filter, then this new card doesn't influence the current data viewed by the client. There is no reason to send this update. And that's something that we can express here in this predicate. So we can say that we're only going to publish this to a particular subscriber in case the ID of the event actually starts with the filter ID starts with that we had with the query. So now we get a more selective publishing of those events. We're going to do something quite similar when there is a redeem. The difference here, of course, that we're not going to update a count card summaries query, but the fetch card summaries query. And we're going to actually transmit the new card summary. So the client gets the new data and can update the data grid accordingly. So in this case, it just so happens that for every event handler, I have a single emit. That's mainly because it's such a simple case. In general, if you would have multiple event handlers and multiple query handlers, it's very feasible that you would do multiple emits here as a result of a single event. That's absolutely fine. This is just a very simple example. So now we're essentially done on our query model side. We are pushing these subscription queries. It's just so that our client side isn't using them yet. They're just getting the initial results. So we need to now modify our client side to do something useful with all of this. So we're going to get to our card summary data provider. Now, an essential difference between a subscription query and a regular query is that a subscription query continues to exist. So it has a certain amount of state and we need to close it when we are no longer using it. So let's create some fields to keep that state. So we're going to have a subscription query result. So the first subscription query result will be for the actual data that we're retrieving. In this case, the initial data that we're expecting from that is a list of card summaries. And then all updates to that would be single card summaries. So this would be our fetch query results. And then we have a second one for the counting. So that would initially get an integer. And then for each update received a card count changed update. and that's our count query results. So now we have some fields to keep those. So let's make sure that we close them if we're done with this data model. Let's implement a close method. So if our fetch query result isn't empty, let's close it, cancel it, and set it to 0. And similarly, if our count query result isn't null, we should cancel it and make it 0. So that's done. Let's make sure we actually call this from our GUI. So we're overriding the close method here. Call our card summary data provider close. Let's remove this redundant exception. So now I make sure that we nicely close these queries. Now, in the life cycle of this data grid in Vaadin, these subscription queries may be initialized many times because Vaadin will nicely just get the data needed to display a single page or a single section of the table in order for it to be scalable, even if you would have millions of records in your backend. So these queries would start over and over again, which means that I would need to take into account here that this query might actually already be available, in which case I would stop it here. So I would have room for a new query. And similarly, when we're counting, if the count query result isn't empty, then let's cancel that and set it to 0. And then finally, to make sure that none of this has any race conditions, let's synchronize on those things using the Lombok synchronizer again. So it's all a bit boring, maybe and boilerplate, but it is needed to make sure this works reliably. Let's get to the more interesting stuff. So first of all here, if we look at this fetch query, currently we're just doing a direct query, and we want to start using the subscription query functionality. So let's see how to do that. We're going to use the fetch query or assign the fetch query results by doing something with the query gateway. We're not going to do a regular query, but instead a subscription query. The subscription query that we're going to execute is the fetch card summaries query. And now we have to tell the query gateway both what we expect as an initial result, as well as what we expect for the updates. So in this case, the initial result is multiple instances of the card summary, and the updates are a single instance of the card summary. So now we have assigned the subscription query. Now looking at what we return, it shouldn't of course be a new query. Instead, we're going to pick something from the fetch query result, which would be the initial result. So there are two fields here, initial result, which is a Reactor mono, and there is the updates, which is a Reactor flux. So let's first access the initial results. We're going to block until we have something. And then actually Vaadin needs a stream instead of a list. So we're going to convert it like that. So now we have our old situation back. We're not doing anything with the updates yet, but we are getting the initial results. Let's do something similar here with the size. So we're going to assign the count query results by invoking the query gateway, starting a subscription query. In this case, it's the count card summaries query. Initially, we're expecting an integer. After that, we're just expecting this card count changed update. And then what we're going to return synchronously is the initial results of the count query results. And we wait for that. So that's it. So now we have our old situation back with lots of stuff around that. So let's make sure we actually also get some nice benefits or do something with those updates. I'll show you how. So here we, when fetching the data from the backend, we already had an idea on what we wanted to do as a result of a change, so fire this event. So let's do so. We're going to take the fetch query result. We're going to look at the updates, which is a flux. I'm going to subscribe. So I'm getting card summaries in. And that's it. So those can be directly relayed to that fire event stuff. So instead of this dummy new card summary, I'm going to take the actual card summary. And that's it. Now it's refreshing that table. Let's also do that when the count changes. So I'm going to take the count query results, going to look at the updates, going to subscribe to the count, card counts changed update. So in the most naive version, I could try to do this. Unfortunately, this is not going to work. This is a bit too simplistic. One of the reasons is that this would actually trigger a kind of a loop. You know, whenever a change like this occurs, it would immediately start reinitializing the queries, which would give unpredictable results. So we want this to start when I'm completely done handling that update. And the other thing is that, you know, when I'm bulk issuing cards and you would get thousands of cards issued every second when the system is running full steam, this would lead to many full data queries, and you don't want that either. So let's fix those two things. So what I'm going to do here is start an executor service. So I have some way of scheduling tasks asynchronously. So let's do it like this, an executor service. We're going to create a new cached thread pool. Now I have this, I can actually schedule this event firing asynchronously. So we're going to execute this. So this fixes actually many problems. It still leaves us with the issue of we don't want to execute this 1,000 times per second, even if we're issuing cards at that rate. Now, to solve that, we can actually benefit from the fact that we have this full Reactor core API here. So all the powerful operations they have on fluxes and other things can be used here. So in this case, what I can do is say, well, hey, here, this update screen, I actually want to buffer that for a duration of, say, 250 milliseconds. And this will limit the amount of times that this executor will actually fire to 4 times per second, which is a much more reasonable rate for this operation. So this should actually be it. So now we should have a fully dynamically updated client. Let's restart the application. So there we go. To really show it properly, it's probably best to show it on two tabs at the same time. So now we can actually see that updates would appear in multiple screens. So if we would issue a single card, you can see actually appear it in both screens. So only the left screen would give the success feedback because that's where the command was executed, but the update to the query model would appear in both screens. And the same thing would happen for redeem. I can bulk issue cards, say 10,000. So you see the query model still being updated in the background. Looking at the logs, when they're a bit silent, we would actually see that there are many more instances of the log where it says that it's projecting an issued event compared to when it's actually doing a new query. So that's why we would see this buffer in action. In general, in this example has very detailed logging, so you can download it and play with it yourself and see in the logs exactly what's going on and how the various things relate. So that would complete the demo. We will have some time for questions now. Before I do so, let me actually push this code. So you can access that yourself. Committing first helps, obviously. So you can now access this code in GitHub. While you're thinking about questions, and please submit them via the chat. One more thing I'd like to ask for your attention for. We have some great upcoming events with AxonIQ and Axon. So in September on the 19th and 20th, we have Axon Framework training in Amsterdam. It's followed by our conference, the Event-Driven Microservices Conference. We have a great summer discount on these events, which would give you 25% discount on the training plus a free conference ticket. If you're interested in that, please contact us. The validity of this offer is limited, as well as the seats that are available for the training. So don't wait too long if you would have any interest in that. So that would be it for now. I'll rapidly take some questions now.